Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Pool Party by Ryan Bell, and here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Also, we have a thermometer rule, where along thermometers, digits increase starting from the bulb. So a valid thermometer here could be something along the lines of like 2, 3, 5, 7, 8. Right? Because it's constantly increasing from the bulb to the tip. And that's how thermometers work. Also, the next rule set is each cell in the grid is either land or water. The land cells form a one orthogonally connected region. That means all the land cells have to be orthogonally connected to all the other land cells. And orthogonally connected just means that they share an edge with. And the land cells all forms one orthogonally connected region. So, for example, something like this would be a valid orthogonally connected region. You could not have something like that connect because this is not orthogonally connected to the rest of the land cells, right? It's only touching diagonally, so it's not orthogonally connected. Also, all land cells contain odd digits, and all water cells contain even digits. So that means every cell that's odd is land, and every cell that's even is a water. Because each cell in the grid is either land or water, and all the land cells contain odds, and all the water cells contain even digits. Okay. All cells containing a circle are land cells. So these are land cells. And cells containing a square are water cells. So these are water cells here. Which, remember, all water cells contain even digits and all land cells contain odd digits. The digit in a circled cell indicates the number of land cells seen from that cell, including itself in the 4 orthogonal directions, where water cells block vision. Okay, so therefore, every circle indicates the number of land cells seen from that cell. So say in the orthogonal directions, which means in the directions that are horizontal or vertical to that cell. So say we had this, right? Say, say this was, well, okay, this is even. Say it was here. And these are essentially C cells or water cells. Any other land cells would be blocked vision-wise by these C cells. So this would specifically then see only 3 cells, 3 other land cells, including itself. Remember, it has to include itself. So this would be a value of 3 here. Oops. If that were the case. And that's how circled cells work. A pool is an orthogonally connected region of water. So again, by orthogonally connected, that means it must be sharing an edge with another water cell in that Yeah, it must be sharing an edge with another water cell, if that's the case. All pools border the edge of the grid, so they must touch the edge of the grid. You cannot have a pool that essentially is surrounded by land, essentially. That's what it's saying. And these are typical cave rules scenarios. So you cannot have, like, say, the land forming a pool like here, because all pools must touch the border of the edge, must border the edge of the grid. And no two pools touch each other orthogonally or diagonally. Okay, that's interesting. So so there could not be something going on like this, right? Because this is a pool, but this is a separate pool because they're not orthogonally connected. But since they're touching diagonally, that's already strictly not allowed because no two pools can touch each other orthogonally or diagonally. And this is touching diagonally. Each pool contains exactly one cell with a square, and the digit in the square equals the number of water cells in its pool. Okay, so say this were a pool, and say this was essentially some form of landmass. Well, or say this was a pool. I don't know. Well, this can't be a pool. Anyways, say, well, I feel like I'm already solving it if I do this, but anyways, let's look at something else. Let's look at another pool. Say this one. Say this pool was like here, and you had a landmass surrounding it. This would say that this pool is 6. So the digit in the square must be equal to the number of water cells in this pool, which would be 6. So therefore, this would be 6 then, if that's the case. And that's how pools work, which are all the square cells. And remember, every pool must have exactly one cell with a square in it. So every cell with a square is in a separate pool. So that's one thing that you know about that. And those are all the rules. It's pretty complex, yeah, I'll admit. But I think this is very easy just because of some things that I see. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. So let's learn how to Sudoku. Okay. Simple thing. Let's start with by coloring all the squares as water and all the circles as land. And all the even digits as water, which is that. So we know this green cell must be odd. And it cannot be 1 because it sees more than one cell. Well, actually, it can never be 1 in a circle because it has to connect with the rest of the land cells. And remember, every land cell is an odd cell, and every odd cell is a land cell. Same with the even cells. All the water cells are even cells, and so all the even cells are water cells. So you can have, at most, 4 water cells in each row, column, and box. Well, actually, you have to have exactly 4 water cells in each row, column, and box. You have to have exactly 5 land cells in each row, column, and box, right? Because there are 5 odd cells in the digits 1 through 9, and there are 4 even cells in the digits 1 through 9. Therefore, this will see at least 3 digits, so this must be green here. This has to be a different one, and if this is blue, the problem is then these would have to be the same amount because these would see the same amount of digits. So this must be green. And this has to see an even amount because we know this is odd. Therefore, these two have to be even to add up to an odd digit, which is here. So these are both odd. This, again, remember, pools cannot touch itself. So these specifically have to be in the same pool. So therefore, this is blue. And every pool is only a pool in one. Each pool can only have one square in its region. In its pool, exactly. So this cannot be connected to this one. So it can't be touching it at all. So these cannot be pools at all because then they would force this to be in the same region or to be touching. So these are all green here. The green has to be connected, essentially, in one mass. So if this were green, this would have to be blue, because again, we already have 4 greens in that box. And this green would then be separated, which is not allowed. So this must be blue, and this must be green. Therefore, this has to be 4, because the pool size is 4. This is all connected. This is either 3 or 5 because it's blocked by here and it's blocked by here at least. It could be 3 greens, it could be 2 other green cells here, but we see at least 3 here. These pools have to be different pools, so they have to be separated. So these are all green. Well, we have 5 greens in column 3, which eliminates green in the rest of the column. Therefore, these are blue. This cannot be connected because these are both squares, so this is green also. This pool has to be an even number, so it's at least these two. This pool is at least an even number, so it's at least those two. If we try to go out more than this, the problem is these would all form essentially this. If you had more than 2, this would have to be at least 4, and then we'd have 5 blue cells in this box, which is not allowed because you can only have 4 blue cells max per box. So this specifically has to be size 2. And therefore, it cannot touch another blue cell. So these are green, right? Because pools cannot touch each other. So these both must be green. We have 5 green cells in column 1 now, which means we can't have any more green cells. So these are both blue. We have 4 blue cells in this box now, which means we can't have another blue cell there. So this must be green. This has to be connected because we know every pool has to have exactly one square with it. So this is blue. This, then we have 4 blues in this box, which eliminates blue from the rest of the box. So this is green. So this sees 3 cells that are land. So it's just 3. We don't know about this. This is at least size 6. We don't know if it continues more. This cannot be a blue cell because then these pools would be touching and they have to be separate pools because they both have a square in it. So this has to be green. These two are separate pools, so these 3 must be land. These are all odd digits. So this is, oh, these are all odd digits, and it has to be continuously increasing from the bulb to the tip. And there's 5 digits. Well, there are 5 odd digits too. So this must be 1, 3, 5, 7, and 9. Therefore, the remaining digits in this box are 7 and 9. This can't be 9, so this is 7, which makes that a 9. The remaining digits here are 5 and 7. remaining digits here, well, this can't be 5 or 7 because of the 5, 7 pair in the box. So this is 1, 3, or 9, but this can't be 3, so these are 1 and 9, which makes this a 3. We have a 1, 9 pair and a 3, 7 pair in column 2, which eliminates 1, 9, 3, and 7 from the odd box, which makes that a 5. That makes this 3, so this must be a water cell because it only sees 3 land cells here. And again, these have to be in the same pool because you can't have touching pools even diagonally, so this has to be the same pool. This has to be different, though, from this, so this must be land. This must have at least 4 water cells, so one of these two is water, which means we have 4 water cells in the box, so the last remaining cell cannot be water. So one of these two is water, we're not sure which, because it can't be just 3 here. We have now 4 water cells in row 2, which eliminates water cells in the rest of the row. So this has to be a land cell. And this pool has to be at least 2 because it's an even digit. So it has to be 2, and we have 4 water cells in row 1. Therefore, that makes this a land cell. So this is a size 2 pool. This has to be at least 4. So this is 4, 6, or 8, but it cannot be 8 because of this 8. This is 2 and 6, but this can't be 2, so this must be a 6 here, which makes this a 2. 2 cannot be here. This must be a 4, which makes that a 2. Remaining digits here are 6 and 8, so this is 6 and 8, 6 and 8. This is 6 or 8, and this is 4, 6, 8. Remaining digits here are 1, 7, 9. So this cannot be 2 or 4, it's at least 6 or 8. Okay. The green has to connect to itself. One of these has to be green because it has to connect to the rest of the green cells. So since one of these is green, that means these both have to be blue. And this is already size 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. Also, the rest of these cells cannot be blue because we have 4 blue cells in row 6, which means these are all land cells. And again, we have a thermometer along this, so this must be 9, 7, 5, 3, and 1. This is already 8, so therefore it cannot extend anymore. Therefore, and it cannot touch any other pool, so these are all land cells. Well, we have 3 land cells here. Sorry, we have 5 land cells in column 4, which eliminates land cells from the rest of the column, so this must be an island. We have 4 water cells. Sorry, not island. 4 water cells in this box, which eliminates a water cell from the rest of the box, so this is a land cell. We have 5 land cells here in the middle box, which means the rest of the cells in the box must be water cells, so these are water. We have 4 water cells in column 5, so this must be a land cell, and it has to connect, so therefore it's a land cell. This is 8 because of the size of the water pool, which means this can't be 8, so this must be 8. This has to be 6. These can't be 8. This is 4, 6. We have a 4, 6, 4, 6 pair in column 4, which eliminates 4 and 6 in the rest of the even cells. So this must be 2 and 8. This must be 2 or 8. This can't be 2 because this is already 2. So this has to be at least size 4. So this must be an island. We have 5 land cells in this box. So therefore this also has to be a water cell. This could be 4, 6, or 8. These are 1, 3, and 5. What else do we have? This has to be the same region pool as this one because it can't be, it has to be touching. So, well, it doesn't have to connect that way. Ah, but if it connected any other way, then this land part in between would not be connected to the rest of the land. So this cannot be land, this has to be water. And that's actually a very common theme here that you would know, right? If for normal cave puzzles, if you have two cells which are the same cell on a diagonal, and one already that's not the same cell, the other one has to be the same cell as the two that are similar on the diagonal. This is 4 or 6. Well, therefore this must be 2 or 8, but it can't be 2, so this must be 8, which makes that a 2. That makes this an 8. The remaining digits here are 2, 4, and 6. Well, this can't be 2 then, because one of these two is a 2. This can't be 8. We have a 4, 6, 4, 6 pair in column 5, which eliminates 4 and 6 in the rest of the column, so this must be a 2. And this must be 4, 6, or 8, but this can't be 8, so this must be 8. And this is 4 or 6. We have 5 land cells. Okay, so this sees 7 land cells. 1, 2, 3, 4, 5, 6, 7. So this must be 7, which makes this a 5. We have 5 land cells in row 4, which eliminates land cells in the rest of the row. So these have to be water cells. We have 1, 2, 3, 4, 5, 6 already. One of these two must be a water cell. And one of these three must be a water cell, so this has to be 8. This has 4 digits that are greater than it. If this was water, the problem is this would have to be a 6. And you don't have 4 digits that are greater than a 6. So this has to be a land cell, which again then has to be 1, 3, 5, 7, and 9, which forces this to be 1. This can't be 1, this can't be 1. This has to be a water cell. And this cannot be 2, 4, or 8, so this has to be 6, which makes this a 4. This is 2, 4, 6, and 8. But this can't be 2 or 8. This can't be 4, and this can't be 6. This cannot be 2, 8, or 6, so it has to be 4. And this has to be a different... So it must contain all the water cells here, which means none of these can be water cells, because these pools cannot touch. So all 4 of these have to be, all 4 of the water cells have to be in this pool, which means they cannot touch this pool. So these are all land cells. We have 5 land cells now in column 7, which eliminates land cells in the rest of the column. So this is a water cell. We have 4 water cells in this box, which eliminates water cells in the rest of the box. So these are land cells. This can't be 2 or 8. This has to be 4 or 6. This can't be 4, so this must be 6, which makes that a 4. We have 1 land cell here. This can't be 4. This can't be 6, so this is 2, 8, 2, 8. We have a 2, 8, 2, 8 pair in row 4, which eliminates 2 and 8 from the rest of the row. So this can't be 2. This can't be 6 anymore because of this 6, so this must be 4, which makes this a 2. This is a 4, which makes that a 6, which makes that 4, which makes that 6. This can't be 4 or 6, so this must be 2. This can't be 4, so this must be 6, which makes this a 4. This sees at most, well, it can't see 1 because it is connected to itself. It can't be 5 because this will see at most 4 here. So this must be 3. So this is 3. This can't be 3 and this can't be 3. So it has to see 3 exactly, which means it must see here. This has to be water. We have 4 waters now in column 9, which eliminates water from the rest of the column. Therefore, this is a land, and these two must be water. So therefore, this must be a 6. This has to be a 2. This must be 8, which makes that a 2, and this has to be an 8. And now this is a pool of size 4, so this is 4, which makes that 6. Now it's just Sudoku, right? Probably. This can't be 9. Where's a 9 in this row? It has to be here. So this is 9, which makes this 7. This has to be a 5-7 pair, and this can't be 7, so this is 5, which makes that a 1. And this has to be 7 then. That means this has to be a 9. This is 1 or 5. 9 cannot be any of these cells. It can't be here, or here, or here, so it must be here. So this is 9, this is 1. These both have to be 7 or 9, and this can't be 9, so this is 7, and this is 9. Remaining digit here is a 5. Remaining digit here is a 7. Remaining digits here are 1, 3, and 9. But this can't be 3 or 9, so this is 1. This can't be 1 or 3, so this is 9, which makes that a 3. This 5 means this can't be 5, so this is 1, which makes that a 5. That leaves a 1 here, and then we have 5 and 3 remaining, which makes that a 5, and a 3 in the middle. And that's how you solve it. Yeah, it is very easy, but you do have to have some knowledge of typical patterns, I guess you would say. And particularly in this one with the pool and the land, this is essentially a cave puzzle where you have the cave or the hollowed out area is one big giant formation, and you have essentially borders here which must touch the edge. And so there's a very specific things you know about this situation to be able to, how do you say it, solve this puzzle. It is very easy, but again, you need some knowledge of cave puzzles, which this is actually a fairly good example of. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.